Hey guys, Will here. So welcome to our 11900K overclocking guide. We're going to be doing things a little bit differently from what you might have seen elsewhere in today's video. I really want to focus this video on those of you who are wanting to overclock your system for maximum gaming or sim racing performance. So we're not going to be shooting for the highest numbers possible here. We're not going to be trying to win any records or anything like that. Just going to be helping you out to, I guess, understand a little bit more about how overclocking works right now in 2021 with the Z590 chipset, as well as, I guess, understand a little bit more about the reasons why we overclock and what kind of performance gains we can reasonably expect from following through this process. So obviously different people are going to have different kinds of hardware in addition to the CPU. So obviously you're watching this is an 11900K overclocking guide, but people have different power supplies, different motherboards, different coolers. I want to try and help out as many of you as we possibly can today, but depending on what supporting hardware you own will ultimately determine the results that you get from this. So I would definitely recommend don't go into this expecting a video where you can just copy all of my settings and get exactly the same results as me. It's more about kind of understanding at a fundamental level exactly what we're doing here so that you can then take that knowledge and apply it to your own individual build. Let's get into this, and what we're looking at here is the BIOS screen, which is what you get if you hit delete as the PC is first booting up. And when you bought your PC or when you had your PC built by a friend or whoever might have built it for you, or if you did it yourself, you may have gone in here and made a few changes, or they may have done some configuration for you to get up and running in the first place. Usually these days you do need to make a few little changes in here, but you can run pretty much at default settings, which are very much not optimized for the best performance that you can get from your system. Now, one of the things that a lot of people don't understand is that these days a lot of the hardware that we're working with is actually designed and developed with overclocking in mind. If you go back 20 to 30 years, overclocking was really something that was done by enthusiasts only. None of the hardware was really designed around doing it. So you really kind of had to know exactly what you were doing to be able to get any sort of reasonable or, I guess, worthwhile result out of overclocking. Whereas these days, there's a lot of things that you can do to maximize the performance with minimal risk and with minimal knowledge as well, which is really great for people that just want to sort of squeeze a little bit more performance out of their PC without necessarily investing massive amounts of time into understanding how all this stuff works. So the things that are going to be of key importance here, obviously cooling. We're going to be running an EK360 DRGB all-in-one cooler on today's build. We're also running a 1000 watt AX power supply from Corsair and running this, as we said before, on a Maximus 13 Hero motherboard, which is designed with overclocking in mind. Now, without going into heavy tech here, the main things that you need to understand are the quality of the components on the motherboard will ultimately determine to a large extent what kind of overclocks you can expect out of your system. Even if you've got a really great CPU, you might have heard of terms like silicon lottery before, which determines how well a CPU will overclock. If you don't have a good supporting motherboard, a good quality supporting power supply, and of course good quality cooling, you're not going to reach those high clocks. So it's important to understand that. The key things on a motherboard are of course the VRM circuitry or power delivery circuitry, and that is what you see underneath this giant heatsink here. So we've got a nice big heatsink on the Maximus 13 motherboard. That is obviously conducive to better overclocking, better cooling, and therefore higher performance out of the system. Obviously, we want to make sure we have a power supply which is adequate for the task at hand as well. When we overclock our CPU, that does, of course, increase the power load. So we do need to, of course, make sure that we have a power supply which is suitable for handling it, and then, of course, cooling as well. So when it comes to overclocking a CPU, generally, there's two different limitations that you're going to run into, either voltage or power limitations or cooling limitations. So what that means is that you're either going to run the maximum temperature, which you can safely run at, and start to get thermal throttling, which is where the CPU slows down, or you're going to run into the voltage limit where it's unsafe to actually push that voltage any further. And often if you get into exotic cooling and high-end cooling, like what we're ultimately going to be doing with this CPU and motherboard in our wall PC build, you do end up reaching the point where it's not so much the temperatures that are limiting you, but rather you're not able to push that voltage any higher without damaging your CPU or at least shortening its lifespan. So we're going to be staying well within reasonable limits today, basically regardless of the hardware you have. And again, just sort of giving you a basic understanding of how all of this works so you can get better performance out of your system. So let's dive in now. We're in the BIOS, as we said before. We've hit our delete key to get into this system. Now, depending again on whether you've had this configured by somebody else previously, what I would recommend you do before you do anything else is going to the tool icon here, or the tool tab, and scrolling down, and we're gonna save this default profile as a profile here. So if there are some settings in here that somebody's put in on your system previously, those are all saved and retained. So if we do have any problems, we can go back to what we know was working in the previous configuration. So in my case, I've actually already got a couple of profiles saved here, so I don't need to do it. But what you would do is just push the key number 1, give it a name of, you know, whatever's gonna make sense to you. So maybe default, something like that, and then just simply hit enter with 1 selected here, and that's gonna save this as a profile. That allows us to then go back in later on and save this again. Once we've saved that profile, we're gonna go across to the exit tab. We're gonna go load optimize defaults, and that is gonna reset the motherboard to its completely factory default settings. We're then gonna hit OK. And then we're gonna go save changes and reset. That is gonna reboot the motherboard. We're gonna see here all the changes that it's making from what the settings were that were in the system already. So obviously that will depend on what changes other people had made previously, and we're gonna hit OK. That is gonna reboot our system. And then we're gonna hit delete again, and that's going to take us back into the BIOS. Now we should actually get a CPU fan error in my case, because I'm not running my all-in-one cooler off the CPU fan header, and I'll explain that in just a moment for you as well. So we're going to hit delete. We're probably going to see an error message here, so we're not going to be alarmed by that if we do. It's probably going to take a little while to come up again because it is having to reset a whole bunch of stuff. There we go. Okay, so there we go. We can see CPU fans error detected. Ensure that the CPU fan is properly installed. And again, that's simply because we don't have a CPU fan plugged into the motherboard, and it's expecting to see a reading there. It's like a safeguard here to tell us, okay, I'm not seeing any cooling on the CPU. That's a bad thing, and it's protecting itself. So it says here, press F1 to run setup. So we're gonna do that. We're gonna press function F1 on this crazy keyboard. There we go. And that's going to take us into our BIOS again. And this is completely factory default settings. So the first thing we need to do is go across to our monitor. So we need to now tell it to ignore the sensors that we don't have anything plugged into. So we're going to go first to temperature monitor, and then we'll go to fan speed monitor. So temperature monitor, and you can see here our CPU temperature is monitored. We've got a couple of here which aren't being monitored, so we're going to tell it to ignore these. So we hit enter, and then we go up to ignore. Same deal again here and here. And then we're going to go back by pressing escape. And then we're going to go down to fan speed monitor. And you can see here the fans which we are getting a reading from. So the reason we were getting that error, CPU fan not reading anything. So we're going to hit enter on that guy. We're going to go ignore. And that is going to stop that error coming up. Now we can tell the system to ignore these other sensors as well that don't have anything plugged into them, should we wish to do so. You don't need to do that because it's not going to halt for errors on those anyway, but just as a good thing to do, you can do that. So we're going to hit ignore on all of those. And now we're going to go back across to our Extreme Tweaker tab. We're going to scroll down, we're going to see AI Overclock Tuner. We're going to set this to XMP1. Now XMP stands for Extreme Memory Profile. The RAM that we're running in this particular PC is 4000 megahertz RAM or 4 gigahertz RAM, 32 gigabytes, and it's XIII RAM as well. So the RAM itself actually has a profile built into it, which you can load onto the motherboard to tell it what to configure other settings as. Now the important thing to understand here is that the memory controller, or the little chip that actually runs the memory and tells it what to do, is actually built into the CPU. So by changing and loading this extreme memory profile, what we're doing is actually configuring some of the CPU settings as well. So as a first thing to do, we always want to make sure we load that XMP profile. So the default speed for DDR RAM is 2400 megahertz. So if you've paid a lot of money for RAM that's faster than that, you want to make sure obviously that you are getting your value out of the money that you've spent there. So that's the reason why we do that. And XMP, you know, is just the easiest way to do this out of the box. So we're going to start off by doing that. We're going to go across to exit. We're going to save changes and reset. We're going to hit OK, and you can see again it's giving you a list of all the things that it's changing there. We're going to hit OK. System will reboot, and then we're going to hit delete again to go back into our BIOS. So we're just going to keep hitting the delete key to make sure we don't miss it. It does take a little bit of time with this particular motherboard to go back in because it is having to change all those settings. And it is also doing a thing called memory training, which is where it runs through a range of diagnostic tests and then loads the profile back in to make sure that everything is optimized. So it is taking a little bit of time here, but I think we're all good. Okay, so back in the BIOS again, and we now have that extreme memory profile loaded. So we go back across to extreme tweaker. And the first thing I want you to do as soon as you've got back up and running is have a look over here at your temperature. That is your CPU temperature there. If you see anything over about, say, 60 degrees at this point, then I want you to stop and I want you to have a look at exactly what's going on with your cooling, because ideally at idle, like what we're doing now, we should be seeing a temperature somewhere between 5 to 10 degrees higher than our ambient temperature inside the room. So it's about 23, 24 degrees inside this room right now. So I'm happy with seeing 30 degrees there. But obviously, if we're seeing a temperature that's a lot higher than ambient, we know that our cooling's not working properly, given that the CPU isn't actually under any real load at the moment anyway. So we're gonna have a look at that first of all. And then if we scroll down, we can see our core voltage is sitting at 0.995 volts. Our core ratio is sitting at 35. DRAM frequency is at 4000 megahertz, as we mentioned before. And our DRAM voltage is at 1.397 volts. So the extreme memory profile for this particular RAM stipulates a voltage of 1.4 volts and then a DRAM frequency of 4000 megahertz with a CAS latency of 16. And we'll talk about that in a little bit more detail in just a moment. So if we move over to the left-hand side now, you can see our CPU turbo mode frequency of 5300 megahertz or 5.3 gigahertz. Target CPU at AVX frequency of 5.3 gigahertz as well. AVX is a different type of instruction set which puts a higher load on the CPU, and we'll talk about that in a little bit more detail later on too. Target DRAM frequency, as we said before, 4 gigahertz, cache frequency 4.1 gigahertz, and target CPU graphics frequency of 1300 megahertz. Now you may have noticed we're not running a dedicated graphics card or a discrete graphics card on this system. We are just running off the integrated GPU on the CPU. So that is likely to limit our overclock a little bit today, but again, that doesn't really matter for the context of this video. If you're not running the iGPU, you can disable that in the BIOS, and that does sometimes give you a little bit more headroom. But again, at the voltages and temperature ranges that we're going to be dealing with today, I doubt it's going to make a big difference. So we'll move on. We keep scrolling down here. You can see a lot of this stuff is going to be set to automatic by default. Our B clock and PCIe frequencies, those should be set to 100. Basically what that's meaning is that our multiplier is making a multiple of 100. So for example, we have our ratio of 35 here times 100, which is our B clock, and that gives us our 5300 megahertz core speed, if that makes sense. So we'll keep scrolling down. We will go through these settings in a little bit more detail later, but what I wanted to show you here first and foremost is, first of all, our DRAM frequency of 4000 megahertz, as we said before. If we go into our DRAM timing control as well, we should see that CAS latency of 16 set here, which is loaded by the XMP profile by default as well. Now, if you are a more experienced overclocker, you can go in and optimize these a little bit further as well. But for most people, there's no real need to do this. You're not going to get a huge performance boost, again, in the context of gaming and sim racing. So it's not really something you need to get into unless you're really wanting to get stuck into overclocking and really maximizing the performance. So next thing we're going to do here quickly as well is go to Digi plus VRM. We're going to set our load line calibration to level 4, which is recommended for overclocking. Now what that does, without going into heavy tech, is it allows the power delivery circuitry to compensate for voltage droop or voltage drop that happens when we suddenly load up our CPU. So when the CPU goes under high levels of load, what happens is the voltage is pulled down a little bit, simply because of the amount of current that's being pulled by the CPU. And when we get a drop in voltage, that can create instability. So load line calibration loads up the power circuitry, loads up the capacitors, and allows them to be charged up so that when the CPU kicks in, the voltage doesn't drop as much. Now there is a bit of a fine balance here between voltage droop and voltage overshoot, so we never want to go too high with our load line calibration. What we can find is if we set this too high, then what will happen is, even though it might hold our voltages a little bit more stable as it reads in the system, and again we'll look at that later on too, what can happen is we get a voltage overshoot or a transient overshoot when we're going on and off load on the CPU, and that can actually be quite dangerous for your processor. So you don't want to go higher here than you actually need to. So level 4 is a good starting point. We're going to set that. We don't need to worry about anything else in here just for now, again for basic overclocking. We can do videos where we go into this in more detail if you guys are interested later on. Now we're going to scroll down to our voltage. Now again, you can see here, because of our XMP profile, we have a DRAM voltage set to 1.4 volts. Now this is, you can see here, reading high. That's why it's colored. It goes yellow when it's a voltage that it thinks is a little bit too high or higher than normal, and then it turns whatever color that is, either purple or pink. I'm colorblind, so I can't tell you. When it thinks that the voltage that you're putting in is, you know, something that you might want to think twice about before hitting enter. Now, because we have loaded our XMP profile here, we know that this is safe for these particular sticks. But again, this is going to be determined by the physical memory that you have in your system and as loaded by the XMP profile. So don't just copy me thinking that 1.4 volts is safe, because it may not be safe for your particular RAM. 1.4 volts is generally the upper end of what people would consider a safe voltage for DDR4 RAM. So definitely don't just sort of copy this. Above that, we have our CPU core and cache voltage, and we're going to be spending quite a bit of time talking about this a little bit later on. But before we go any further, I wanted to actually boot into Windows, run a couple of quick tests and see how the system is actually performing before we go any further with our voltages. So before we do that, just looking down here as well under prediction, this is actually quite a powerful tool here. So what it does is it grades our CPU quality as well as our cooling by a point system. So you can see here 186 points. Those numbers are kind of a little bit arbitrary. They don't really mean anything. But down here, this is the information that is quite useful. So non-AVX voltage required for 5.3 megahertz. It's saying 1.544 volts at load line calibration level 4. And then for a heavy AVX load, it's saying we're going to need 1.575 volts for 5.3 gigahertz across all 8 cores. Now, that voltage is way too high for you guys. I wouldn't recommend going to those kinds of voltage levels unless you're doing some sort of a phase change cooling, or you're an enthusiast, let's just say. Even for me, running, you know, high-end water cooling, which is what we'll ultimately be doing on this system, I wouldn't want to go higher than about probably 1.45 volts on the V-core. For you guys, I would recommend not going above 1.4. So what we're going to do is we're going to start off just with automatic. I want to show you how it behaves, and then we'll go in and we'll make some adjustments to that a little bit later on. So we know that for 5.3 gigahertz across all 8 cores, we're going to be looking at a voltage of around about 1.54 volts, which is too high. So that is going to be the upper limit of what's going to be possible. We're going to be looking at some sort of a frequency underneath that for our overclock. So let's go across now to exit. We're going to just save those changes that we've made to the load line calibration and boot up into Windows. So booted up into Windows now, there's a couple of programs which I like to use. And again, there's a lot of different schools of thought here, depending on exactly how you define stability. And I do have a video discussing exactly how I test stability, which I'll link down in the description below for you guys. I don't want to go too far into that today, but obviously we will need to do some stability testing to make sure that the settings that you guys end up with are sufficient and stable for what you're wanting to do. Obviously, if it's crashing all the time, that's not going to be any good. So I would definitely recommend downloading CPU-Z as well as Asus Extreme. Now, Asus does have a trial period. That is usually sufficient to kind of just get you through the overclocking period. If you're wanting to do more extreme stuff and more long-term testing, you're probably going to have to pay for it. But you know, if you're just wanting to spend a couple of days getting this dialed in and then never look at it again, then the trial version is absolutely fine. So we're going to boot up the trial version now. And we're going to click on the little line graph up here, and that is going to bring up our system stability tool. And you can see here under temperature, we've currently got our motherboard CPU and our CPU cores 1 through 4, as well as our Samsung SSD. We're going to click on preferences down the bottom here. We're going to make sure that we have all 8 of our cores visible. Whoop, that was 6. Sorry, I got a little bit of lag on the mouse here from the system that we're using to record the screen. So 5. All the way through 8. And then once we've done that, we hit OK. And then we're going to click on CPU ID down here. And that brings up our little interface so we can monitor clock speed and voltage. So we can see here at the moment we're sitting at around 5.1 gigahertz. It is dipping down to 4.8 occasionally. We are using CPU clock speed scaling at the moment because we haven't adjusted any of those settings just yet. And we can see also the core voltage is adapting relative to the load on the system and the core frequency as well. So that's the reason why we're seeing our core voltage jump around. When we enable this stress test, or when we begin the stress test, we should see that clock speed jump up to the maximum allowable under the settings that we have for all 8 cores being active. Remembering again that depending on the number of cores active will ultimately determine the maximum clock speed. We should also see that core voltage jump up too. Now we want to keep a very close eye on that, because if we see anything over about 1.4 volts, we're going to want to stop straight away. And this is why I always caution people not to use automatic settings unless they know exactly what they're doing, because you can end up in a situation where the CPU is subjected to voltages which are much higher than what it really should be. So we're going to click start, and let's keep an eye on that. We can see there 1.44, which I'm okay with, but again, I'm not going to recommend to you guys. And you can see there it's clocking down to 4.7 gigahertz, which is quite slow for a voltage that high. And you can see the temperatures are already peaking out at 100 degrees there because the voltage is so high. So I'm going to stop that straight away before we do any damage. It's not really at a level where I think it's going to damage the system, but I certainly wouldn't want to be running that. And that is, in my opinion, quite an inefficient overclock, because you can see when we're running under full load across all 8 cores, we're clocking all the way down to 4.7 gigahertz, and we're also running at a very, very high core voltage, which is unnecessarily high. And as a result, we're getting high temperatures, which is going to induce thermal throttling. So what we're going to do now is we're going to close all this off. We're going to go back into the BIOS and make some adjustments. So back in the BIOS now, we're going to go back across to Extreme Tweaker. We're going to scroll down to, where are we? Asus Multi-Core Enhancement. We're going to set that to enabled, remove all limits. Now we do need to be very careful from this point forward, because this does allow us to push those voltages on the core, as we said before, into dangerous territory. So we are going to want to do a little bit of management here. SVID behavior, that can remain auto for now. AVX related controls, we're going to go in there. We're going to set an AVX offset. We're going to scroll down to ratio offset per core. We're going to set that to user specify, and we're going to set it to 2. And that's going to allow us to clock down the CPU based on AVX load. AVX, as I said before, does place the processor under heavier load and therefore increase temperatures as well. So this is just the way that we can scale the CPU clock down a little bit, just under AVX load, to keep things in check. So you may find you don't end up needing this, but as a starting point, I will always like to start off with 2. Then we can go up from there if we find we're able to ultimately. So we can exit back out of that now, hit escape. So now we're going to scroll down 1 to CPU core ratio. Now on previous Intel processors that we've done overclocking guides on, we've ultimately been able to achieve all 8 cores running at the same maximum clock speed. With the 11900K, that's a little bit more difficult, simply because we are able to push some of those cores much higher. And as you'll see in just a moment, there are generally 2 cores on each CPU, which are always going to clock higher than the other ones do as well. So we'll look at that in just a moment too. We're going to go into core ratio. We're going to go, instead of sync all cores, which is what you've seen in previous videos, by core usage. So we'll hit that. And then we're going to start off at a clock frequency of 5 gigahertz. So we're going to set our ratio to 50. Remembering again that we have our B clock set to 100. So 100 times 50 equals 5 gigahertz, as we had before. We're going to go ahead and set that limit to 50 for all 8 cores. Now again, this is just a safe limit, which I think most people should be able to achieve with this CPU. If you do end up having problems, we can reduce some of those other cores a little bit later on. But what we're ultimately going to try and do is actually push some of those cores a little bit higher without going past our maximum safe voltage. So we'll start off with 50. We can go up from there later on. So we're going to go into the next one now, specific core. This is what I was talking about before. So this allows us to set specific limits for each individual core on the CPU. And this is something that's new to the latest generation of Intel processors. So previously, you didn't have any specific control over the individual cores, only what their limits were as a whole. Whereas now with the new series, we can actually control the limit for each individual core on the CPU. So you can see here, we have a little asterisk next to 2 of our cores. Those are our 2 best cores on the CPU as determined by the data that's actually on the CPU itself. So again, because we are setting limits here at 50, we're going to match those and just set 50 across all 6 cores, or all 8 cores, I should say. And then we can exit out. And then we're going to go all the way down past these other guys. We don't need to make any changes here just for now. Remember, before we did already go into Digi Plus VRM and make sure that that was set to level 4, recommended for OC under load line calibration. Don't need to worry about adjusting any other power limits or anything like that. I know a lot of guides do suggest setting the maximum duration power limits. Again, for the context of what we're doing here, I'd rather just leave those auto. So we're going to keep going down. Don't need to worry about any of these other settings for now. Again, our ring down bin, our CPU cache ratio, max cache ratio, and graphics ratio can all stay on automatic for now. Be clock aware adaptive voltage, I'm going to disable that. And then I'm going to set my CPU core cache voltage to manual. So this is again where you might see what I'm doing here vary from what you might have seen elsewhere. Now, remembering again that this system is dedicated to gaming and sim racing. The only time I ever switch this on is when I'm doing either of those tasks. So what I'm happy to do here is make a little bit of sacrifice in terms of power efficiency, because whenever this system is running, it is going to be running, you know, at 100%. But what's also really important to understand here, and I think where a lot of people get confused, is that just because we're setting a manual voltage and manual clock speeds doesn't mean that the CPU is going to be running at 100% and generating a whole lot of heat all the time and using a whole lot of power all the time, maybe more importantly. This is where I've seen a lot of people trip up because they think that just because we're setting these maximums, it's running that way all the time. So the CPU is actually only going to consume marginally more power and perhaps output a tiny little bit more heat under these conditions as what it would do under adaptive modes. The reason they have these available is so that you can optimize energy efficiency. And that's of course very important for some usage cases, just not so important for what we're going to be doing here today. But what I really need you to understand here is that just because we're setting a fixed voltage and clock speed doesn't mean that the CPU is going to be running at 100% load all the time. And heat output and power consumption are relative to CPU load, not to voltage and clock speed. Obviously, if you raise those limits, then that also means that you're able to consume more power and therefore generate more heat. It doesn't mean that you're going to be doing that all the time. So I just wanted to make sure that that was 100% clear for you guys. So we're going to go ahead now and set that to manual mode. And then what I'm going to do is I'm going to set my CPU core voltage override to 1.4 volts, which, as I said before, is what I would say is the upper safe limit of what I would recommend. Now, you may find that you need to run a little bit lower than this. So again, do your own research here. Don't just take my word for it. This is with an all-in-one 360mm radiator here. If you do find that your temperatures are pushing into the 80s, then I would recommend lowering the voltage a little bit more. So do keep an eye on that. Again, as we said, from this point forward, we are needing to keep a close eye on our temperatures until we know exactly what's going on. We'll discuss some stability and temperature testing a little bit later on too. So 1.4 volts there for our CPU voltage override. Just so happens to be the same as the voltage that we have for our particular RAM that we have here too. So what we have now is a scenario where the CPU is going to be sitting at 5 gigahertz all the time, regardless of what's going on, except when it's under AVX load. Remember, we do have that offset of 2, so it's going to jump down to 4.8 gigahertz under AVX load, and it is going to be sitting at 1.4 volts all the time as well. So what we can do now is we can go back across and save all changes and reset. Again, we can verify the changes that we made here. So we enabled multi-core enhancement. We set our AVX offset to 2. We set all of our limits by core usage and set all of them to 50. And if we keep scrolling down, we set those individual core limits to 50 as well. And then we also set our voltage override to 1.4 volts with the voltage set to manual. So that's all good. We're going to hit OK on that. And that should boot us back up into Windows. Okay, so we're back up in Windows now, booted successfully, no issues with crashing, which is always a good thing getting into Windows. We've got Asus64 up here running again with our CPU ID window here, so we can monitor our voltage, which you can see there is sitting at 1.39, 1.4-ish volts, which is what we set as our manual voltage. We will see that droop a little bit under our load condition because we do have our load line calibration set to level 4. If we were to raise that, then we would see a more stable voltage, but again, at the cost of overshoot, which we don't want. So again, I don't recommend going over level 4 for your load line calibration. And you can also see now our clock speed is sitting solid at 5 gigahertz. So we're going to hit start on our test now. And what we're wanting to do here is keep an eye on 2 things before we hit start. So our temperatures, we want to make sure that they stay below about 80 degrees is where I'm comfortable recommending to you guys. If you're comfortable with the cooling that you have and you know what you're doing, you can go higher than that as long as you haven't removed any thermal limits, of course. We do want to make sure that we have that thermal protection enabled. But yeah, under 80 degrees is generally what I recommend for CPU temperatures. And again, we want to make sure that we don't get any craziness going on with our core voltage either. So we're going to hit start. And what we should see now, there we go. So you'll remember before we had our clock speed running down to 4.7 gigahertz, I think it was. You can see it is going down to 4.8 again because we do have that AVX offset. So this is the behavior that we expected. But importantly here, you can see our CPU core voltage has drooped down quite a bit, which is what we were expecting to see. But our temperatures are now going nowhere near what they were before. So we're running a lot more efficiently. We're running the same, if not higher clock speed, much lower voltages, and much lower temperatures than what we were seeing before. So from here on in, basically it just comes down to a balance of stability testing and yeah, just upping those frequencies until we reach the point where we start to get instability and then stepping back a little bit. So let's go back into the BIOS now. I'll show you how to make those fine-tuning adjustments, and then we'll talk a little bit more about stability testing. So back in the BIOS now, and really what it comes down to here is just finding the right balance for your particular system. So we're gonna up those frequencies slightly. We're gonna take small steps there without increasing our voltage any further. We know that for this particular system, our temperatures were within a safe range. Now, one thing that is really important to understand is that a small little test like what we just did before isn't indicative of what the maximum temperatures are gonna be over time with the CPU. So we don't actually see those maximum CPU temperatures until the water has reached its maximum temperature. And depending on the amount of water you have in your system will ultimately determine how long it takes to reach that maximum temperature. But again, that's a topic for another video, and we do have some detailed videos already where we went into that in a lot more deeper explanation. So let's just push on here. But we will be doing longer term stability testing in just a moment for those who might be wondering. So we're going to go back across to Extreme Tweaker again. And let me just basically talk you through the process of doing this. So what we're going to do now is decrease that AVX offset slightly. So we're going to go up here. We're going to set our AVX ratio offset value to 1. We're going to hit enter, and then we're going to go back and do those same tests again. Normally I'd like to test for about 15 minutes initially, just while I'm finding the point that I think is stable, and then do more long-term stability testing once I think I've found the stable point. Otherwise, if you're doing a test overnight every single time you change something, it's going to take you weeks and weeks and weeks to find the stable point. And again, remembering that what we're trying to do here is, get you up and running as quickly as we can without a massive amount of time invested in understanding how all of this stuff works. So for me, when I'm overclocking a system to the absolute limit, sometimes it can take me up to 6 months to actually find, the absolute maximum while still maintaining stability. So, that's the kind of things that you're doing at the really high end. So we're going to start off with 1. If that's stable as well, then we'll set it to 0. We'll keep going basically until we find the point where it becomes unstable. We can't go higher than 0. So at a value of 0 here, that essentially means we have no AVX offset. So regardless of the type of load that's on the CPU, it's always going to be governed by those ratio limits that we set in the other page earlier. So what I'm going to do is set that to 0 now, because I know that on this particular CPU, I am able to run a 5 gigahertz AVX load, and that doesn't cause me any problems. And for that reason as well, I'm also going to set this guy here to manual, or user specify, and 0 as well. Then I'm going to hit escape. And then, as I said before, it's basically just a case of increasing these core limits as well as our specific core limits, remembering that those are what govern the limits for the individual cores, and basically just raising those until we find the point that is most stable. So generally what I find with these CPUs, and I have tested a few of them now, we can generally get at around that kind of 1.4 volt limit. We can generally get 1 or maybe 2 cores up to 5.4, 5.5 gigahertz if we're lucky. And then for 3 to 4 to 5 to maybe 6 cores around 5.3 gigahertz, and then 5.1 for all 8 cores. So when you've got all 8 cores active and under 100% load, it's going to be coming down to 5.1, 5.2 gigahertz. If we're running a game, for example, that's only utilizing 1 core, then it's able to run at a higher clock frequency. So what we need to do to achieve that is simply set our 1 core limit to, say, maybe 5.5 gigahertz. 2 cores, maybe if we're lucky we might get 5.5, but I know for this CPU I'm limited to 5.3. 5.3 is okay for me at 3 and 4 core. And then once I get into these guys, I need to do 5.2, 5.2, 5.1, and 5.1. So just to explain that once more, if I'm only utilizing 1 core, I get 5.5 gigahertz through to 8 cores where I'm down to 5.1. Now we also do need to make those changes in our specific core limit as well. And remembering again, the ones that have the asterisks next to them are the best cores in the system. So those are the ones that we're going to want to set to the highest number. So 5.5, 5.5, and then we don't want any of our other cores going above 5.3 gigahertz. Remembering again that this is just sort of like an upper limit. What's actually going to control the ultimate clock speed is those other settings. So if we do find that we've got one particular core that's running really hot under our monitoring software, or we have one particular core that when we overclock it too high, it starts crashing, we can set a manual limit on that individual core, and that will ultimately govern what that other setting is able to achieve and how it actually determines which load goes on which cores, if that makes sense. So you can see again why it can take months and months and months to get this, really dialed in. But again, this should be pretty good for most people at around that sort of 1.4 mark. This is what I was able to achieve on this particular particular CPU. If you do find that you are crashing, you might need to lower this to say 5.4. If it's still crashing, go down to 5.3. And again, just experiment with different types of load to see where the stability point is. It really just does come down to fine tuning. But the important thing here to understand is that we don't want to go over that 1.4 volt mark. What you'll need to do is ultimately, if you want to reach higher clock speeds, increase that voltage, but then you become thermal limited because your temperatures go too high, and it just becomes this constant sort of exchange of, are you voltage limited, are you thermal limited, are you clock speed limited, and so forth. So I think for most people, you should be able to achieve something quite similar to this with the 11900K at around 1.4 volts. Of course, assuming that you have adequate cooling to keep it under that 80-degree mark at 1.4 volts. So let me now go across, and I'm just going to load the profile that I actually had in there ultimately to show you exactly what we ended up with. So I'm going to go to my tool here. I'm going to go down to Asus user profile, and I'm going to load, what was it, 5.5 singles where we ended up. So profile number 3, and load settings from profile. And if we go back across here, there were a couple of other little changes that I made. I actually ended up managing to do 5.5 gigahertz, 5.4 on 2 cores, 5.2, and then down to 5.1. And then if we go into AVX related controls, I actually did end up having a AVX offset of 2 with those higher clock speeds. But again, if you were running it at 5 gigahertz, for example, you're probably not going to need that AVX offset. So again, it's just sort of a trade-off and a balance between the two. And if we keep scrolling down here, you should see, go back out to the main page, my voltage should still be set to 1.4 volts, which it is. So we're going to load up into Windows again now. And let me just quickly take you through some of the stuff that I do for stability testing once I've kind of got things dialed in and I think I'm happy with them. All right, so just to quickly show you where we ended up with the overclock on this system. Again, remembering that we will end up ultimately fine-tuning this even further once we've got it running up on the custom loop and we're not running the integrated graphics as well. I would imagine we can probably push it a little bit harder when we're not relying on that graphics chip, which is integrated in the CPU as well. But just to give you an idea here, remember again, before we were running at 4.7 gigahertz all the way up at, I think we were pushing almost 1.5 volts, and we were running into temperature or thermal throttling at up to 100 degrees per core. So with a little bit of tweaking, if we hit start here, we can see now 1.323 volts under load. So we do have that little bit of droop there again because we don't have our load line calibration set overly aggressively. We're running a CPU core clock of 5 gigahertz, and that is under AVX load. And our temperatures are there sitting at around about the sort of 70 to 85 degree mark. Remembering again that as we do start to load up the temperature in the water here, those temperatures are going to go up, and we'll talk about that when we get into longer term stability in just a moment. But you can see this so far is nice and stable, no problems whatsoever. So we're going to hit stop on that again. Again, I would recommend running this test for at least 15 minutes just to make sure that those temperatures don't get out of control. But once you're happy with that and everything's stable, you haven't had any errors, we're going to hit stop. And what I want to do now is close off the Asus software and show you a couple of other titles that I like to use for my longer term stability testing. Now, I have many years of doing this kind of stuff. You know, I started back in the early 2000s when we were using Prime 95 for stability testing. Where I've landed, and again, other people will disagree with me, you know, other people will use different things, but this is just what I do. I like to use a program called, well, 2 programs. One program called OCCT, which is a free download. It is donationware though, so you can unlock some additional features and testing for longer periods than 1 hour if you do make a donation. We haven't unlocked it yet on this system, but I will go ahead and do that once we get into fine tuning and testing on the custom loop later on. So what I really like about this software is it seems to pick up errors in certain areas which other software, including Prime 95, doesn't tend to do. I've had systems which I thought were completely rock solid stable and then gotten occasional crashes in games and things like that. When I'm running this testing software, I tend to find that if this crashes, other things will crash. If this doesn't crash, then I never have a problem anywhere else either. So again, in the context of gaming and sim racing, this seems to be a really good test. Another thing you'll notice in this software is that the temperatures on the CPU cores don't go quite as high as they do with some other tests. That's simply because this is a more realistic workload. It's not just smashing the cache over and over and over with short FFTs. It's actually loading data into the memory, then bringing that across back into the CPU. So it's giving the CPU a bit of a break between packets of data, which does help bring the temperatures down to a little bit more of a realistic level. So generally what I find here is under 100% stress test loads, at the default settings, which is what we're going to use for our testing, we do tend to see the same kind of temperatures that we see under 100% load when gaming as well. So I'm trying to keep this as relevant as I can for you guys. So load up the OCCT software. We're going to select the medium data set under CPU, not LinPack. We're going to set extreme mode. We're going to set load type variable. Start at cycle 1. Instruction set we can set to automatic. Now, if you do want to test between AVX loads and standard SSE loads, you can choose those specifically here as well. So remembering again that AVX does place a higher load on the system, so you will see a little bit more heat. I'm going to leave that set to automatic for the purpose of this test. We're going to hit start here. And again, because this is donation where you can see it's got that little pop-up, we will pay for this on this system a little bit later on once we get into the custom loop testing. So we're going to let that count down. I'm going to hit play. And again, we wanted to keep an eye on a couple of things here. So we'll see underneath here if there's any errors pop up. And then we can see our core temperature there, 47 degrees, 52 degrees, CPU package 53 degrees. Our core VID is 1.5 volts. Now it's important to understand that the VID isn't the same as the vCore. So don't be freaked out thinking that that is super, super high. Another thing you can do, and what I like to do, is open up that CPU Z program that we talked about before as well, just so we can monitor our core clock and our core voltage in a little bit more detail while we've got this running as well. There are other tabs that you can use here to monitor those things, but I just kind of like to have the two open at once so I can see exactly what's going on. So again, you can see because we do have AVX going on at the moment, that's sitting at 5 gigahertz. Our core voltage is sitting at 1.35 volts. Again, we do have that little bit of droop because of the amount of load that we have on the CPU. So we probably could actually push that load line calibration a little bit higher and push those cores a little bit higher if I really wanted to, given that our temperatures are well within our safe range at the moment. But again, for what I would recommend for you guys watching the video, particularly if you're beginners and you don't really understand exactly what's going on here, these are what I would say are pretty safe limits. But again, do your own research here. So normally what I would do is, provided that this lasts an hour, I would pay for the software. I would let it run overnight, make sure it's nice and stable. And then if you do want to try and push those limits a little bit more, you can. This is what I found was stable. So what I do is I would stop that test. And then I open up another program, close this off, open up another program called RealBench. Now this is a free download as well. And what this software does is it runs the system through a range of realistic tests using things like Blender, video rendering, tasks like that, runs it through a range of things which are simulating kind of real life scenarios. So rather than just sort of smashing the CPU with, unrealistic workloads, not that OCCT really does that, but this is more replicating what you would be doing on a normal sort of desktop machine. So again, we click on stress test. We set the duration to the maximum, which in this case is 8 hours. We hit start. And again, we just wanted to keep an eye on our clock speeds here. You can see at the moment we're not under AVX load, so it's sitting at 5.1 gigahertz instead of the 5 gigahertz that we saw under AVX. And again, our CPU core voltage is sitting at a nice stable rate, not getting any crazy spikes or any big droops or anything there. So that's nice and stable. And again, we can see our temperature here on the CPU is hovering at around about 65 degrees, which is well within our safe range. So we can say here pretty safely with even with the 360 millimeter radiator that we have here. Again, remembering that we haven't achieved heat soak in the water yet, so the temperatures will go a little bit higher. But we can safely say here at 1.4 volts with the 11900K, we're more voltage limited than thermal limited, which is fantastic. And it really goes to show just how well these EK all-in-one coolers really do perform. For the majority of people, you're probably not really gonna need anything more than this, even with a beefy CPU like the 11900K. So I would now let this sit and run for the full 8 hour duration. I would probably go and run some other tests as well. And once I'm happy with everything, that is pretty much it. As long as your temperatures are in check, your voltages are in check, and everything is nice and stable, as long as you're not getting any other crashes or any other funny business, you should be good to go. Should be pretty much set and forget, and you shouldn't need to touch anything pretty much ever again. So there you go, guys. I know there was a lot of things covered in this video, and I did say it was a beginner's guide, but overclocking is quite a complex thing, and there are many, many things that we can dig and dive into a lot deeper than this if you really want to get into the hardcore stuff. So let me know in the comments if you would like to understand more about exactly how I go about really fine-tuning and getting into the nitty-gritty of all of these settings. But hopefully this has helped you guys out for a quick and relatively easy overclocking process. Again, remembering that we are sort of looking specifically at gaming and sim racing PCs here. I wouldn't shouldn't be using fixed voltage and core ratios for desktop PCs that are being used for things like web browsing and, you know, just general desktop duties, because it is overkill. It is unnecessary power consumption. But again, do remember that just because we're setting our voltage at a set level and our core frequency at a set level doesn't mean that the system is running at 100% all the time. I guess the best way to describe it is it's kind of like, you know, buying a bigger stereo doesn't necessarily mean that the music is louder unless you crank the volume up. You can kind of think of the volume like CPU load. So I guess that's probably a good way to explain it. So that's it, guys. Hopefully the video has helped you out. If it has, leave a thumbs up. Let us know in the comments below as well what kind of performance you're able to get out of your system, whether this has helped you or not. And thanks for watching, guys. We'll see you again soon. Bye.